talk about this literature, all those things. 2, maximum 3 or slide. Within 4th slide, you should go to your work. And the remaining 10 slides should talk about what you did, what result achieved, what this one, something like that. At least 15 slides should be there, including this one. And you will give a given. But that PPT you should make and get approval, because both the abstract and as well as the PPT should be approved from your guide and mentor. Guide is many of it that generally it is going to be your company person, and he should approve or put some signature, approved signature. And also you have to send it to the report. You cannot directly upload. It should be the abstract should be sent to your guide, and he should approve somewhere in the corner, and this one without his approval cannot upload. So that means you have to make now. Don't send last day, previous day, I was busy with my company, these, that, all those things. They won't approve because they won't see it. They have a lot of work. Correct? You have to send, and possibly you have to call and tell him that I send the report. Sometimes you send your mail, process are busy. Correct? It is your responsibility. He is your mentor and our guide, whatever may be, IIT professor. You have to tell him that you have sent the report and remind them and send it at least a few days before. Then you have to upload this one that drive, Google Drive, HOD office, they will give a Google. There you have to this one. If you send late, they will reduce marks. They intimate the committee. Don't lose marks. This because even though I am not this one as a coordinator, but I thought I want to tell you, and you may receive. But don't do it on last minute. Many times students send to the guide approval of the abstract and the PPT should be approved by them both. Okay, because sometimes it's that IIT, because last year, previous batch something, the IIT professor said he never shown it to me. Otherwise, you will send tomorrow your this one midterm viva means tonight you send it to IIT professor for the sake of just sending, and they won't even see. Correct? Don't do that. That's what I'm just advised. That's more than okay. I think we'll start our class. So this this one you have to make and send it. The format, people will go on asking format is very simple. It should have title, student name, guide name, and also your company where you are okay. Somewhere you can mention, and below that your mentor and guide both the names, and then introduction to project. That means why you are this one. Then literature survey, then objective of the project, and methodology. What are steps you will be doing. Then about work showing what did you do. Methodology. After that, the work completed. Work completed will be on heading, or there you show what and all you did, what result achieved. Work to be completed, and when you will complete that, you have to be there. I think I stop here because we need to come start our class.
Sir, everyone has come, sir. Thank you.
Yes, please. Yeah. Thank you. Yeah.
Thank you.
You are able to see the screen, correct?
Yes, sir. Yes, sir.
Yeah.
Sir, DC motor, BLDC motor.
Yeah. Correct. Okay. Today we are going to see the last type of motor used in vehicles. I am talking about used for driving your vehicle, because you have other type of stepper motor, all those things, they are not used for driving your vehicle. Correct? It is used for the control purpose or small application, but not in electric hybrid vehicle as a prime mover, which is going to drive your vehicle. So we are talking the today we are going to see what you call as one kind of DC motor called as brushless DC motor. Correct? BLDC, brushless direct current, short form of BLDC motor, because this is going to work with DC power, not from AC power. Okay, alternating current. That's why we call as a DC motor. It is a improved version of regular DC motor. Already we talked about the DC motor 10 or 15 classes, 10 classes before, extensively, different type of series motor, shunt motor, how they are working, torque equations, all where they are used, and the characteristic input of current versus torque, speed versus torque, all the curves we saw, and with this one. But anyhow, for you to, since we are talking the improved version of DC motor, I just start with the basic DC motor. This will be useful for your DC motor. You know, basic DC motor consists of two magnetic field. One is called field magnet. This is called as field magnet. Please note that here it is shown as a permanent magnet, but basically there it is a coil. Already we know that there are two coils. Generally, it will be represented like this. We give a voltage plus minus VF. So this is called field coil. This is supplied with VF. So the IF current is going. Because of that, there is a phi of magnetic flux. Then I have another coil, which is called as, this is symbol for armature coil. Please note that inside there is a coil and I am supplying voltage VA plus minus IA. So it produces phi A. So we know that torque equal to K into phi F into phi A. This is the basic equation. The K is a constant which depends on number of poles, many properties already. K already used, I am not going to explain. So these two magnetic field interacts. Because of them, they repulse each other and create a torque. That is what is shaft power. And this multiplied by omega is going to give the electrical PE, correct? The PM, mechanical power, equal to torque generated in the shaft. Of course, there are losses. This torque I told you generated TG. I told that you call TG generated torque, but this torque TG is greater than T shaft. Correct? T shaft, this is T shaft. Correct? So omega into this one, which correct? T shaft multiplied by omega is the power available in the shaft. This is called motor power. I said that PG. PG is equal to omega into this one, but omega is not going to be there because by that of friction all starting, correct? So there are two magnets, two magnetic field generated by electromagnets, correct? These are called electromagnets because you are supply voltage, current flow, magnetic flux. Supply voltage, current flow, magnetic flux. They interact in this one. Basically, this one. These are the basic electric motors or DC motors. But for understanding purpose, I told you what is the difference between DC motor, regular DC motor, this one. I have the field magnet. Here it is shown as a permanent magnet for understanding purpose. It has a north pole, it has a south pole. Please, it has shown as a two pieces, but you can think as a single piece. It may be a single piece, right? It can be single piece also. And it has north and south pole. We know that when this is a north and south pole, automatically there will be a magnetic flux moving from north pole to south pole shown with an arrow direction. These are magnetic flux, correct? That is called phi F. This is nothing but phi F. Right? Now, that is the field magnet. The other magnet is called armature magnet. Armature magnet is shown here, armature coil. Correct? Here it is shown as a understanding purpose. Please note that it again understanding. I am supplying a DC voltage, which is nothing but VA. Correct? Field is created by a permanent magnet for understanding purpose in this picture. The armature magnetic field, phi A, is created by this VA. We are applying a voltage to the armature coil. Please note that here armature coil is shown as single coil. That's why I mentioned as armature coil is single turn. But actual motor, multiple turns are there. Right? Multiple turns. So that the more current will flow, more current, more magnetic phi A will be higher. We know that torque is proportional to phi F and phi A. Higher the flux density of phi F and phi A, more torque is generated. Correct? So in the actual motor, the number of coil, field coil and armature coil will be more. But here, for understanding purpose, we have shown that it is a single turn, this one. Now, I am being the armature is an electromagnet. So we need to supply a voltage. The voltage, we are supplying a DC voltage. You see that battery I am giving plus minus. This voltage needs to be connected to the armature coil. The worst part is the armature is rotating object. Correct? It is rotating. Now, if I connect a wire from the battery terminal directly to this red color one, which is the armature wire, which is rotating, and this wire which is connecting, this wire will get twisted. Correct? One rotate, two rotate, wire will get disconnect. It is not possible. Then how will you have to supply voltage to the armature coil with a single turn, multi-turn, which is rotating? We need what you call as a commutator arrangement. So this is the orange color item I did mention, which is called as made of brass pieces. In between this part is a insulated. Please note that again it is a circular, this one only like this, but this part is a insulator. Correct? There is a cylindrical brass piece which is cut in the center with, and it is filled with non-insulating material. That means this is one half, first half. This is second half of a conducting brass or any conducting material that is made of the commutator, solid bar, some having some thickness, some diameter. In the center, it is made to put together, glued together or bolted internal something by using a separator, which is the insulator. So that two halves are this one. And from this each half, the one end of the armature coil is connected. Correct? That means this commutator along with the armature coil will rotate clockwise or anti-clockwise. In both ways, depending upon this one, motor can run clockwise and depending upon the voltage supplied to the armature coil from this. That we will see here later. So that means the power from this battery is given to armature coil through the commutator. Correct? Commutator is connected to coil. Commutator and coil are rotating. Correct? There's a shaft, all those things. Then how will you power with this one? So you have the carbon brushes. Correct? You have the brush 1, brush 2. Two brushes are connected to the battery and the brushes are fixed. It won't move. It is connected to body of the motor. So, but it touches. The brush surface is touching the commutator, permanently always touching. Now, if the commutator rotates clockwise or anti-clockwise, the brush will, through brush, the voltage is supplied. Correct? So that's why it's called brushed DC motor. It is also called as brushed DC motor. Power to the armature is supplied to commutator using the brushes. Okay. Now you can see that the positive is connected to the first half. Correct? Of the commutator. This is the second half. The negative is connected to this one. Now we know that when you give the power, automatically the current will flow. The current is shown here. Correct? So from the battery plus current goes through the carbon brush. Carbon brush is touching the commutator first half. From that, the wire is bonded to it, physically welded or this one. So the current goes like this. Right? In this direction, it comes out this one. Then it comes to the second half. From second half, it comes to the second brush and circuit is closed. These are current flows. Once current flows, this is called IA. This current flowing through conductor is a phi A. Correct? This phi A will react with magnetic flux. Correct? Magnetic field magnetic phi F, already shown in blue color line from the north pole to south pole. Now, what happens? Now current is from the commutator. It goes to left side loop. This is called left half. I can say that. I can say left half coil. Correct? This is my center. This is my left half coil. This is my right half coil. Okay. Now we can see that the current from the plus enters in this one through this, goes through, flows through the left half of the armature coil. Okay. Wherever current is entering, correct, that part, we know that the electromagnet, that will become a south pole. Correct. Where is current entering? The left half coil. Correct. From the positive it enters. That means this part, this wire, here you will get phi A, which is a south pole. Now it goes like this, comes like this. Now it is coming in the reverse direction, this opposite direction. This will become north pole. Phi A, north pole. Correct? You can see that here north pole, here south pole. Field magnet, what is this? This is north pole. The armature coil also, because the current is flowing from this direction, become north pole. Correct? Current is coming out and current entering. So north pole, what will happen? There will be repulsive force. Right? North pole of the field magnet, permanent magnet, pushes the electromagnet, because this right of the armature coil, current is coming in this direction, entering this, leaving the coil. So it become a north pole. The already one north pole, repulsive force. So repulsive force, for example, it pushes downwards. That's why the downward force is created by these two north pole. One is field magnet, permanent magnet, electromagnet, this one. Similarly, here you have south pole, field magnet, the armature coil, because current is entering. Please note that whenever current is entering, that side will become south pole. So again, the south pole will push up, because this is pushing down, this pushes up. So that is what I shown here. Due to the current is this one, this is south pole, here this is north pole. North pole pushes together, and the south pole, there's a force created. Up force, F, up force, down force, because of this one. Same magnetic poles. Okay, that means what will happen? The armature will start rotating this direction. Correct? Will start rotating this direction. Pushes up. So what will happen? The coil will come here. I can show that for understanding purpose. Correct? Then the coil will be something like this. Come down and connect here. So it has rotated 90 degree because they're pushing up. By the time it comes here, please see here, still, even if it comes here, still this is touching, correct? The positive is touching. By the time what will happen? This north pole will attract the south pole, correct? This is south pole, still it is south pole. The bottom side is north pole. The north pole is attracted by the south pole of the field magnet. The south pole of the armature is attracted by north pole of this one. Initially, there's a pushing, 90-degree pulling. Then finally, what will happen? Here, this will become south pole. Here it will be north pole after the rotation. Okay. By the time what happened? Because they are rotated, the brushes are constant. Then the coil which was flowing current has come here. Again, the current direction changes. Correct? Then this will rotate. Correct? Again, same thing. Every 180 degree, the commutator brush arrangement changes the direction of the current, so that the armature field is such that one side pushing, other side pushing. But after off, both will pull. Correct? So the armature start rotating. So here the main drawback is this arrangement. Correct? To supply the current to the armature, we need a commutator with brush arrangement. So that means if this brush will be always touching the commutator, there is a friction. Correct? Friction happens. Correct? Because of the wear and tear. Wear and tear happens. Apart from that, since current is connected, disconnected, every time off circle happens, there will be sparks are created. And because of that, electromagnetic interference is happening. This is the major drawback of DC motor, brushed DC motor. Correct? So that means every year, frequently, depending on whether the motor is continuing, you have to change this whole mechanism, brushes, commutator, you have to remove, and motor, we have to rework, all those things. They may not drawbacks. Apart from that, it is creating a spark. These motors cannot be used in a gas and where flammable gases are there inside the mines or wherever the fuel vapors, petroleum industry, all those things. If you need chemical industries where flammable gases are around, if the motor runs, it can create a spark like a IC engine, and it can create fire accidents. So these brushed DC motors are not allowed in a location where the coal mines, where methane is there, chemical factories, or in case of petroleum industries, where flammable material, you cannot use this. So there is a drawback. So they wanted to find out, can we have another one? So that is what called a brushless DC motor, correct? Brushless DC motor in which again it is a DC motor. It needs two fields. One is called armature, other one is called field. Field main armature that is there, correct? In case of BLDC motor, brushless DC motor, since the armature is made of, here in brushless DC motor, they call not as armature, correct? They call something like rotor. We know the rotor name is used in induction motor, AC induction motor, DC induction motor, synchronous motor. We already saw permanent magnet synchronous motor. We saw they are only used to the same terminology. Nowadays, they are using even in the BLDC motor, because BLDC motor, you are supplying a voltage, time varying voltage like AC, correct? We know normal DC motor, VF is a field voltage, for example, 100 volts, and VA, armature voltage, maybe 100 volts or 50 volts. Two voltage sources you are giving, both are DC voltage, constant DC voltages. But in case of BLDC motor, the rotor or the armature is made of permanent magnet, which is called as rotor. So they want to use same terminology, like where the applied voltage motor is not a DC voltage. Instead of that, time varying DC voltage, correct? We don't call it AC voltage in BLD motor. What we are supplying called time varying DC voltage, and because we are going to supply from directly from battery, we are going to in subsequent slide, and the voltage will be connected, disconnected, correct, to the coil, correct? So because of that, we voltage 0 volts at some instant of the time, in some instant it will be 100 volts again. So that means voltage will vary something like this. 0 volts, 100 volts, again it becomes 0 volts, again 100 volts, something like that, to the field coil, correct? Field coil, we are going to supply a DC voltage. Please note that voltage will vary 0 to say 100 volts, 0 to plus voltage, or 0 to minus voltage. It can come minus side also. But again, you have plus voltage, minus voltage, and 0 volts. You are switching between two DC voltage. That's why it's called a DC motor. But it is a time varying voltage, correct? At some instant, it will be 100 volts. So it looks like a square wave, correct? Sometimes it come a pulse width modulated wave also, correct? On time, off time will be different. So that's why this is here in the BLDC motor, the rotor is not called as an armature. They called as a rotor, because in AC motor only the rotating part is called the rotor, correct? And the stator part, where the coils are fixed in the body, there we are supplying AC voltage, correct? Sinusoidal voltage we give in case of AC motor, correct? Synchronous motor we saw, and induction motor, and permanent magnet synchronous, all these things, the stator is supplied with AC voltage, sinusoidal voltage, three-phase voltages or two-phase voltages, correct? So it is a sinusoidal voltage. But in case of BLDC, we are supplying DC voltage, but it will be connected, disconnected like a square wave. So why I'm explaining is, so in the DC motor, BLDC motor, the rotating part is called as rotor, not armature, correct? Similarly, the non-moving part, which is a body where coils are there, that is called as stator, correct? Not called a field winding. So in BLDC, even though we call DC motor, we call it as stator winding and rotor. Okay. Another thing is, in brushless DC motor, the rotor is made of permanent magnet. Okay. We are using brushless DC motor. The rotor is made of permanent magnet. This is the rotor. You can see that it has north and south pole, but only thing is its shape is cylindrical, shown here. Or it, in some books, they show something like this also, correct? They can show something, this is north pole, this is south pole, but generally it will be cylindrical shape, correct? And two halves, correct? It will show, for understanding, but it has north and south pole, correct? This is the shaft, motor shaft. This is the rotor magnets, two half, one is south pole, half pole, semicircular together. So this is the rotor rotating part. So it's a permanent magnet. So you don't need any voltage. Correct? There's no need to supply any voltage like a armature in case of regular DC motor. Other one is it consists of 3 or 6 or 8 or 12 stator poles. Correct? You know that the projection is called as pole, P-O-L-E. Correct? It uses, for example, this is a 3-phase. Correct? Sorry, extremely sorry to call 3-pole. Correct? It is a 3-pole. Phase means we are talking AC voltage. Here we are supplying DC voltage. Very sorry, it is called a 3-pole. Correct? Stator coils. And the stator coils are wound over poles, pole pieces. This is called as a pole pieces. Correct? You can see that there are pole pieces on which there are 3 coils. I call this coil A, B, and C. Correct? 3 coils wound over projecting poles. These are called stator poles. It is 3-phase. These 3-phase stator coils will be supplied with DC voltage. But not always. When one coil receives voltage, other 2 coils may not get the voltage. Correct? For example, A is getting voltage 100 volts. That time B and C no voltage. Can be. Correct? There are different way of driving. We call driving waveform, no voltage. Correct? Then for some amount of time, for example, from 0 to some time, say 1 second, coil A is supplied with 100, B and C no voltage. I say that VA, VB, VC, these are 0 volts. I can say different colors so you will understand 0 volts. After some time, this will become 100 volts, coil B, and coil C and D still 0 volts for this duration. After some time, you can see that the coil C will become 100 volts because you see that this will be same amount of time, equal amount of time. During that time, other 2 coils will be 0 volts. Okay. Then again, what we'll do? It repeats. Correct? Coil A, then coil B, sorry, B is going up, then C is going up. During this period, you can see that 0, 0 volts, 0 volts, this is 0 volts. So this is the second cycle. Correct? So this is the first cycle, this is the second cycle. Right? So what happens? Now, what happens? I am going to tell you in the subsequent slide. So first we'll understand it has a rotating coil. There's a rotor which is made of permanent magnet. Stator has coils. Please know that we are in the stator. We are going to supply time varying DC voltage. That's now I showed you. For some amount of time, one coil will be supplied with full voltage. Other 2 coil no voltages. And after some time, the first coil 0 volts. Second coil is supplied voltage. Third coil still 0. After some more time, third coil 100 volts. Coil A and B 0 volts. So because of that, the coil creates the stator coils create what you call an electromagnet. They become electromagnet. So now you can see here, I am supplying a voltage here VA. Correct? This is my VC. This is my VB. VB is 0 volts. VA equal to 100 volts. Correct? This also, VC also 100 volts. Now, and since I am supplying a voltage, the arrow shows current flowing, IA. Correct? Where the current is entering to this coil. Correct? This end of the, you see the whole thing is, this is one coil where current is entering. The coil is wound like this. Correct? Over the pole piece of the stator pole A. Current, you can see the arrow is shown here. And finally it comes down and goes to this. Okay? So current flows through like this. Okay? I told you in the previously slide, wherever the current enters, that part of the coil will become south pole. Please note that in this diagram, south pole means blue color. North pole means red color or maroon color. Correct? So this is south pole of the pole piece. Which pole piece? V coil A has pole piece on which coil is there. Current enters at this end. So this half of the pole piece become south pole and current enters. Current is leaving here. Correct? It is leaving here. So this become north pole. So north pole is shown in red color. South pole is shown in the blue color. Okay. Now again you can see here this coil. This I call C coil. This is the A coil. This is the B coil. What in this diagram, what we should, I told you, we can supply sequentially one after another or other way also. Sometimes we can give two coils simultaneously and they will make one pole will become north pole, other pole become a south pole. Together they generate more torque. That is what this figure shows. Correct? Okay. Now, since this is south pole, my rotor is currently in this axis. Correct? Rotor axis is this. So this is south pole, this is north pole, and this coil current entered in this side. Correct? Current entered here. So this become north pole, and current is correct. So sorry, very sorry. Current entered here. This becomes south pole, and current comes out. This is north pole, red color. But what about here? Current entered here. This is south pole. This is north pole. At time t, this one, two coils power this one. This south pole will be attracted by north pole of the coil. This coil, which coil? Stator coil A. The pole is north, correct? Which is towards the rotor. So that means north pole will attract south pole of the rotor. So this rotor start moving like this. Simultaneously, at the same time, for the coil C, this is coil C, I given voltage simultaneously, but current flows enters here. So this becomes south pole. South pole will repulse. This is south pole, this is south pole. It will repulse. So this pole produces repulsive force. This pole produces attractive force. Correct? So that means there are two forces acting. So the torque produced will be double. Correct? So that means I am going to show the timing diagram in one or two slides. You will see that this is also one way. That means simultaneously A is given, B is 0, C is given voltage. Correct? C is given voltage. Generally, only thing is, another thing important to note that the polarity of the electromagnet. Correct? Polarity of the electromagnet, that means the coil which produces electromagnet depends upon where the current is entering. Correct? Current is entering this side and leaves. Wherever entered, it becomes a south pole. Where it goes, it will become north pole. Correct? Similarly, current enters here. This is south pole. Comes out. This is north pole. Correct? That is one thing. Otherwise, what you can do is you can excite such that opposite side you can give voltage, negative voltage like this. This is positive. VA will be supplied with positive voltage. VC will be supplied with negative voltage. Okay. So that means current can enter here. Current can enter here like this and come out like this. But we need to give minus V voltage. Correct? So if you give minus V voltage and this is given plus V, A is supplied with plus V. Okay. And this is supplied with minus V. Then current can enter same place and come out. So you will see two types of waveforms. Okay. So now for understanding but this as that, see the rotor which is simply achieved by sequentially. Think about only 1 volt, plus voltage 0 volt 5 volts. Correct. So VB is not there. VC is supplied after some time. Correct. Just a minute. Let me. Yeah, this is So VB become high, low, then VC become high and low, correct? By doing this, the rotor can rotate 360-degree. Again, the pattern repeats. So by giving sequentially supplying stator coils with the DC pulses, I call the pulses, correct? Duration till it reaches, correct? 3 pulses so that the rotor rotates 1 full revolution. Okay, this is basic operation. So to control the rotor speed, the magnitude and direction of current flow through the stator coil matters. So more torque has to be produced. Torque is proportional to phi, correct? Torque is proportional to phi F and phi A. In this case, I will say that phi stator, because being this one, phi rotor, of course, there's a motor constant, correct? Torque produced in a brushless DC proportional to stator coil magnetic flux and rotor coil in this one. These two are proportional to IS, and in case of the permanent rotor, it is fixed. You cannot change because it is a permanent magnet. Correct? IS multiplied by phi R into constant. Correct? Phi R is magnet, but of course, IS is going to produce this. That means I can say that T is directly proportional to IS. Correct? Into Km, where Km equal to phi R. Correct? This is a permanent magnet multiplied by K. K is called as the motor, this one, some constant. So that means I can say that since only stator voltage, how will you vary this? By varying Vs. If I vary Vs, phi Is will vary. If I varies, phi S will vary. So torque will vary. So that's what I'm saying. By varying the magnitude of the voltage applied and direction of this one, whether north or south pole, the torque direction and can be controlled, and speed of the motor can be controlled. So in BLDC motor, another one thing, I told you in the DC motor, when the coil, left coil, this is called left side coil, this I call a right side coil. After 180-degree rotation, I keep this voltage, correct? This voltage like this, the current will flow from positive of the battery to left side coil like this. How long? For 180-degree. Once the coil rotates 180-degree along with commutator, the commutator is connected to the left half of the commutator with this coil, left half coil is connected to negative voltage because this has come here and this has come here. Correct? So every 180-degree, the current direction changes. Correct? The current direction changes. Since current direction changes, the armature is rotating 180-degree, current changes. 180-degree, current. Who is changing current direction? The commutator along with the brush arrangement. This is done by mechanical, correct? This is a mechanical arrangement which is done by the commutator brush arrangement. They call mechanical commutator. But this has a lot of disadvantages, correct? Spark creation, wear and tear, friction, losses, all this is mechanical. So that's why we will go for BLDC. So in this case also, we need to, what we are doing, I told you, the rotor, which is nothing but armature in the DC motor, is made of permanent magnet. So that means you are not supplying any voltage or current. So you are not commutating the voltage. Commutation is changing the current direction. Correct? Is done in this one in the armature. In case of DC motor, here rotor is a permanent magnet. There is no voltage at all. So that is not that. But instead of commutating or changing the current direction or the amount of voltage applied to the this one, here we are changing the voltage applied stator coil. Stator coils are fixed, they are not moving. Please note that they are fixed, but still to make the rotor, attract the rotor, and so the rotor will rotate, torque is produced. So that means I have to attract the north and south pole of the rotor by magnetizing the stator coils, correct? So this is north pole, so this attracts. This is south pole, this pushes. One is pushing, this is pushing, this is pulling, correct? one pole is attracting, other pole is, that means I have to apply current or voltage, correct? Only I change the current direction. If this is current direction, if I say it is negative, this is positive, correct? Current is entering here. So once this comes one rotation, then I will energize this and this. What I will do? I will de-energize this. I energize this, and then what I will make? I will make this south pole. This will become north pole. Correct? So the rotor was like this. This is south pole. This is north pole. Okay. So this will push. This will pull. So for 120 degree. Correct? So again, what I will do? This will be south pole. This will be north pole. Again, so that's how we are making, right? So that way we can make the rotor to rotate. So changing the polarity and current direction, magnitude and the voltage and current direction in stator winding, correct, is called as commutation, correct? That is how we are achieving electronically. Please know that we are applying voltages, no mechanical commutator brushes, correct? Electronically we are applying this using what you call electronic switch. Coil voltage is controlled electronic switch. Electronic switching can be a transistor or a MOSFET, correct? Or it can be any other switching device, electronic switching devices. We'll see that what it is. So the current, the voltage applied to each coil for some duration is to be controlled. That is called a commutation. So we are called electronic commutation, supplying the stator coil with voltage at appropriate time in particular sequence. That is very important. That is called electronic. This one, in case of brushless DC motor, commutation is applied to stator coil, not to the rotor. But in regular, this one, the commutation is done to armature, which is rotating part. Field coil, we are supplying constant DC voltage. That you have to remember. To achieve the continuous rotation of the rotor, the stator windings are energized in particular sequence, and the position of the rotor can be known precisely so that when to energize can be done. Correct? So blind, there are two type of controller there. One is called open loop control. Other one is called closed loop control. Correct? That means I supply for 120-degree angle or particular amount of time to the coil A with 100 volts, coil B and C 0 volts, or coil A with 100 volts, current flow direction in positive, and coil C with negative. So current going to this one. So one will push at this one. So there are the voltage you are applying. Correct? And I apply for known amount of time. That is called a open loop control. Correct? But it will not be very precise. In order to find whether the rotor is rotated properly and reach the particular location so that I can give voltage, change voltages to coil A to coil B and coil to C, the sequence, I can use sensor. Generally, what you use a Hall effect sensor, they use what you call rotor position sensor, no doubt. Correct? Rotor position sensor, generally they use Hall effect sensor. Hall sensor can detect magnetic flux, no doubt. It can detect magnetic, which magnetic flux? Rotor magnetic flux. Correct? Rotor is rotating. It has north and south pole. Whenever north pole comes near the Hall effect sensor, it will produce a positive voltages. Correct? So whenever north pole comes, then it will produce. So they use 3 Hall effect sensor positioned near each of the stator coil. Correct? You have 3 stator coil. Correct? You may put one Hall effect sensor, head sensor here, another head sensor here, another head sensor here. 3 sensors. Correct? Whenever north pole comes, this fellow will give a high voltage, generally 0 to 5 volts. Now, if south pole comes, it becomes 0. Correct? So again, when the north pole comes here, this fellow will give 5 volts. Correct? A pulse. Again, this will give a pulse. So by deducting this pulse, I know that my rotor, north pole of the rotating rotor has come near this. Correct? Whenever north pole is there, this fellow will give 5. These two fellows 0 volts. Correct? Because north pole of the rotor is near this, not near here or here. Now, if rotor comes something like this, correct? This Hall effect sensor will give 5 volts, correct? Like this. So this Hall effect sensor, there will be 3 Hall effect sensor position near the stator. That voltage will be given to the controller, who is going to generate the pulses. So you can see that in brushless DC motor, it is advantageous. It has a lot of advantages, but still you need a controller which produces pulses in appropriate sequence. Then you need a Hall effect sensor to know whether the rotor has come to the particular location near the particular pole, so that that pole voltage can be switched off, next pole can be switched on, so the pole will be attracted. Correct? So you need 3 Hall effect position sensor. This increases cost of the BLDC motor, but still it is worth having this. Sparks are not clear, wear and tear is not highly rugged, correct? All those things. Then BLDC motor uses the Hall effect sensors and an embedded controller, because where it is embedded, stator, right? Near the stator, the sensor, this one, rotor positions will be detected by this. Okay. Then before going further, I want to tell BLDC motor. There are 2 type of BLDC motors, because don't get confused. Correct? One is called as in-runner type motor, other one is out-runner type. Runner means running, correct? Which is running? Rotor. Rotor is running. This correct. So in case of in-runner BLDC motor, these are the stator coils. So this is the body of the motor on which poles are there, and we correct rotor stator poles, which is fixed to the body. Body is not rotating. There are coils, 3 coils. This will be supplied with these voltages. Correct? So the rotor is shown inner. Correct? The rotor is this. It is a permanent magnet. You can see north and south pole, permanent. This is a rotating part. If rotor is rotating inside the motor, center part as a core, it is called in-runner BLDC motor. You have outrunner type BLDC motor, in which the rotor is body, correct? Body, correct? Rotating, but please note that still there is arrangement has to be done. There will be rotating part, which is outer, correct? The stator coils are inner, correct? This kind of BLDC motors also used as some application in which the stator is inside, but it is not moving. Stator is not coils, nothing is moving. Current is given, constant wires are there. Wires will not get twisted because it's not rotating, even though it's inside. But body, runner is outside. The rotor is in cylindrical with some thickness. These are the magnet, it will run. Correct? So this is called an outrunner type BLDC motor. You will come across, see it, don't get confused. That's why I shown this. At advantages and depending on some applications. Many times the small motors running in tape recorders or many appliances, home all those things, they use outrunner type BLDC motor. Correct? But bigger motor generally will be in-runner. Please note the small motors can also be in-runner type. So don't say that, sir, I saw some motor, very small motor, only 500 watts, 200 watts. This one working at 100 volt, 50 volts. That is also the rotor was rotating. So will be there for this one. Now, to make you to understand further, as already I explained how it works. Please think that simple basic working of BLDC motor. Just I wanted to show you. Correct? Already explained to you. As I told you, the simplest way is there are 3 poles. Correct? This is the voltage we are applying. I can say V supply. V supply. This is coil. Here it says the phase A, phase B. Correct? It is nothing but coil A, coil B, coil C. Correct? So best thing is simplest control, open loop control means for some amount of time, I supply voltage to the coil A. During the time, this voltage 0, coil C also 0. After some time, exactly almost near, I make the second coil energized for same amount of time. Please see that this is time based. That means motor manufacturer will change this duration, and see that it rotates, correct? The 120 degree, rotor rotate 120 degree. One rotor rotated 120 degree, the second coil is energized. Then the third coil is energized, same amount of time. So this repeats. This is what I already told you, correct? This is one cycle. Phase A, during the other two coils are not this one, and this is phase B is energized, correct? So the rotor, we energize this, correct? So then what will happen? South pole is created, correct? So please show that there are two ways to show. The south pole is created, the rotor is north pole. This will attract this fellow, correct? So the permanent north pole of the rotor is here. The south pole is here, correct? This is the south pole. So this will attract. Okay, attraction, repulsion, both can be done depending on how you take, correct? So it comes here. Once it comes here, for this duration, how many degree? 120 degree, correct? After that, I make this coil B with Vs. I will say Vs, supply voltage. Okay, so B, this is B. That time this is off. So the rotor was something like this. It was aligned something like this. So this is north pole, this is south pole. You can see that this is rotated so many degrees. Now I am making this coil, so this will be attracted. So from here, it will be attracted. It will come and align something like this. Right? So again, north pole. This is north pole. Okay, this is south pole. So by sequence making, I'll be able to get one rotation. Again, repeat. So as I told you, torque produced in the motor depends on how much torque produced depends upon angle. What is they called as magnetic angle. So right now, this is the magnetic of this coil. Correct? This is become north because this is 0 volts. This is 0 volts. So this has come here. Now this is getting attracted. So similarly, if I supply this one, the angle decides, correct? K is the constant multiplied magnetic flux of the stator coil, magnetic flux of the permanent magnet rotor. All you multiply with the theta. When it aligns, this one sine theta equals 0, that time what will happen? This will become, torque will become almost 0. Then by that time, I give the next coil. So it is attracted. That's how the basic BLDC motor works. Okay. So already told you, this figure shows how the Hall effect sensor used, correct? Hall effect sensor will produce a voltage 0 volt, high means 5 volts, and this may be 0 volts. Correct? Hall effect sensor, this voltage will be given to the controller. Controller is going to drive. So this circuit is called a bridge circuit. Correct? It's called a bridge circuit. You can see that this is the supply voltage, V supply, given to the stator coil, stator voltage. Please see that we are applying DC voltage plus minus from battery, not alternating. But of course, voltage is connected, disconnected, looks like a time varying 0 volt, 100 volts, correct? Goes up and down. But this is not DC AC voltage because it doesn't have like a sine wave oscillating above, up and down, correct? Sinusoidally. So we are not generating AC voltage, we are supplying DC. That is given to collector. There are 6 transistors, correct? I say the T1, T2, T4, T5, T6. So you can see that this is called collector, this is emitter, this is the NPN transistor. You can already we talked on the mechatronic. Tomorrow we are going to talk about transistors. Okay. Transistor 3, this one, base, collector, emitter. Emitter is shown as a arrow, correct? Collector, there is no arrow. The arrow is coming out, you call NPN. If arrow is going, it call PNP. There are 6 NPN transistor connected like this. Collector. This is collector, emitter, this is base. Correct? Collector, emitter, base. Collector, emitter, base. Correct? You can see that the emitter of the T1 transistor is connected to collector of the T2 transistor. Correct? The collector of T1 transistor is connected to plus voltage of battery. The negative of the battery is connected to emitter of the second transistor. Correct? These two are connected in series fashion. Correct? This is called as push-pull connection. Two transistor connected like this. One transistor emitter is connected to collector, and the first transistor collector is connected to plus VCC supply voltage. Second is connected to negative voltage 0 volts of the power supply. So together they work as a pair. They call push-pull pair. Correct? So these two push-pull pairs are used for driving one coil. Correct? The center point is where it is connected. You can see that this wire goes like this, connected to this coil. Correct? Here the coils are mentioned as U, V, W. I can make it A, B. Better. Okay. So then you can see the Hall effect sensor. This is the Hall effect sensor, which is going placed near the pole A. Correct? A coil. This is Hall effect sensor placed. Sometimes, please note that sometimes the Hall effect sensor may be placed between two pole pieces. This is one pole piece. You can see that this is middle. And this angle. Correct? This angle is 120 degree. It is placed in the middle from this after 60 degree. Correct? You can see that sometimes it can be placed near. There are a lot of possibilities. Well, one thing is they want to know where the north pole of the rotor at the given instant. If this rotor comes here, correct? If this rotor comes something like this, this will become plus 5 volts. Correct? So if the rotor comes like this, sorry, this will become plus 5 volts. So the job of the Hall effect sensor is to find out current position of the rotor. Okay, that is done using this BLD's motor. Okay, now this bridge will be controlled. Correct? The bridge will be controlled by giving base voltage B1, B2, B3, B4, B5, B6. Okay, by giving, if I switch on this transistor, I give plus 5 volt to this, correct? And give, so what will happen? Current from this will enter, go like this. It goes because I am not switching on this transistor. Instead of that, I connect like this. Current goes to this coil, correct? Enters in the coil. Finally, it comes out. Correct? You can see here it comes out, and then through this coil, it comes out, finally ends here. What I do is, I give plus 5 volts here, a pulse, and also here 5 volts. Okay, so this transistor and this transistor will be switched on. So the current from this one goes to this one, flows to the wire into this coil and comes to this coil, then finally comes out. Okay, so as I told you, this is south pole of the rotor, and this is south pole of the one coil stator. This is the north pole of the second coil. So this fellow will push, this fellow will attract. Correct? So this coil is south pole that pushes the rotor south pole. The south pole is attracted by the second coil because this is north pole. So together this and this, they pull the rotor and rotor start rotating in clockwise direction. During the time, this and this transistor will be on together. Okay. Next, when it comes here, then I will switch on this. This will be switched off. These two. This will be switched on. So the voltage from here will come here, enter, correct, and go through this and come out in another coil. For example, this through this coil, correct. So it comes here and through this it will come out and complete. Correct. So by that is how it works. Let me stop here. because tomorrow we will see how it works, what are advantages. Whatever I explained, the H bridge with more clear pictures are there, how the voltages and the sensor, correct? This is the Hall effect sensor. This signal will be used for switching on the base of the particular transistors. Who is going to generate? One microcontroller, correct? One microcontroller will be used for driving your motor. I will show that next class. Thank you. Please give your attendance and see you tomorrow.
Sir?
Yeah.
Sir?
Yeah,
Sir,
yes, please.
Sir, today is I think 24th class, sir.
Yeah.
What is the post?
Yeah, up to the to what I will cover this BLDC. Stop up to this BLDC. But tomorrow it will be over.
Okay, thank you, sir. Thank you.
Okay.
Sir.
Okay. Yeah. Thank you, sir.
Okay. See you tomorrow. Please give your attendance before leaving.
Thank you, sir.
Yeah. Thank you. Take care.